Hi, Chris here with Dot Product for your latest handheld 3D scanning product tutorial. In this video, we'll be demonstrating the new staircase scanning capabilities built into the latest release of Phi3D version 2.2 on the DPI-8X or DPI-8X SR handheld 3D scanners. I'm broadcasting live now from Phi3D 2.2 on the DPI-8X handheld 3D scanner. As you see, I've set up some April tags on my staircase for scanning. As usual, you want to spread these evenly throughout your scene and loop back to them while scanning. However, in this case, you want to make sure you also set one up on at least every landing that you'll be capturing, and you also see I have one on the wall. The first step to enable the staircase scanning functionality is to go to the Settings tab and check the box to use Stair Capture Settings. After checking that box, when I go back to scan, you'll notice that I don't have my usual Start Scanning button in the top right, but instead a Make Settings button. So you want to go ahead and tap that, and this window will come up next. And it's asking you first off how many landings you'll be scanning. So in this case, I have 4 landings, the bottom, the top, and 2 in between. So I'm going to set that at 4. This is also a reminder that the distance to the stairs that you're scanning should always be between 1 and 2 meters, pointed directly straight onto the target. You should have no people or objects moving in the background. And of course, as always with dot product scans, you should never have any duplicate April tags in your scene. And once you've hit confirm, you'll now see that that button has changed to a start scanning button. But before I select that to start my scan, I'd like to quickly review the staircase functionality that we'll be completing here during the scan. As you see, we've already indicated we have 4 landings, and those are going to be the most important piece of the staircase scanning functionality. We are going to have to flag each of those planes during our scan, and they will be locked in as parallel landing planes. So we're going to flag the first one here with the April tag first, the second, third, and fourth throughout our scan. While flagging each of those 4 landings, we also have the option to flag any walls that are perpendicular or parallel to each other within the scene. So you may not have any walls like that, in which case you would just flag the landings. But in our case, we do have parallel walls throughout the scan. So I can flag up to 4 walls at any different landing, as you'll see while I scan. We can track our progress of capturing these landings and walls using the new vertical bars that you see underneath the system warm-up bar. The first wider bar indicates the number of landings that have been captured. So this will have to be filled up in its entirety before you can finish your scan because it is set based off of the number of landings that we set earlier. So that bar will move up a quarter at a time until it is full to capture each of the 4 landings, in our case of a 4 landing scan. Each of the 4 thinner bars will always be there, but are not necessarily required to be filled up in their entirety for your scan. They're representing each wall that you're capturing. So these are perpendicular or parallel walls, for example, in a standard cubic scenario. In our case, we do have 4 perpendicular walls throughout our scan. You won't be able to see them all from every landing, but you'll want to flag as many as you can while you're scanning. So with that, we want to hit the Start Scanning button and get a start on our capture. That April tag should be the first thing you recognize, and you want to turn that landing nice and green before selecting Hold for Picking Plane and capturing that first plane. You'll notice the green bar underneath System Warmup has gone up by 1, and now I want to recognize the wall as well, and the next bar will start to go up. So that's up to 4 walls per landing, and the first wider bar being the landings themselves. So now you've noticed that I've got my wall in front and wall on my left, each gone up by 1, and I also have my first landing in that wider bar. So that's an indicator of how many planes you've recognized during your staircase scan. Now some staircases may not have any walls that are flat or perpendicular or parallel to each other, in which case those 4 thinner bars should be left empty. The only one that is required is those 4 landings. So you won't be able to finish your scan until you've flagged each of the 4 landings. So you see now, as I flag that second landing, that fatter bar starts to go up again. And I'm adding more walls to the second, third, and fourth vertical bars as well. So now that I'm flagging this wall for the second time, you'll notice that that second bar gets higher. So this is just some easy tracking to see what you've captured. But the gist of it is that as you move up the staircase, you turn everything green as always, making sure you've captured it in the highest level of quality. You capture and loop back to your April tags whenever possible, and you flag each of your landings and then also any walls that you can see from that landing that are parallel or perpendicular to each other. So I'm leaning back now to capture the far wall again, and we'll see that third vertical bar go up. It's always good practice to loop back over April tags whenever possible, so I'll just grab that again and then continue up my staircase. Warning me to slow down a little bit as I approach my third landing. Of course, capture the April tag first, turn it green, and then hold for picking plane. And again, I'll do the same for each of these two walls. So this is very similar in functionality to the parallel plane constraint feature demonstrated in an earlier video on Phi3D 2.2. However, as you see, it is designed specifically for staircases, and you're flagging these landings and these walls only in a scenario where you are confident that they are, or you want them to be, parallel in your reality and in your resulting data. In the case of this stairwell here, I definitely want to lock those in nice and flat. And this is a nice added constraint to improve the quality of your resulting data, especially given the case that it's very challenging to close the loop or loop all the way back to your start point when scanning a staircase. So now that I've gotten to the top landing, I flagged the April tag and my final landing plane. And now you'll notice that that first bar on the bottom has turned fully green and it says scene is ready for optimization. However, I do still have a couple more walls that I want to flag up here. You may lose tracking, especially given the challenging nature of staircases. And due to that, you have to relocalize on an April tag. So you cannot relocalize on standard non-April tag areas as you may in other scanning procedures. Because the staircase frames are so similar throughout your scan, we do require that you lock back in on an April tag. So if you lose tracking, like I just did here, you just move back to any one of those tags you scattered throughout your scene, and it'll find itself very easily. So that's just an important thing to remember is that when using the staircase scanning functionality, you must relocalize on April tags. So I'll flag the final wall here. It's going to require me to get a little bit closer. Turn it a little bit greener. There we go. And then I'll slowly move back through my scene, loop back to the April tag for loop closure. And then I'll just flag these walls one more time before I finish my scan. So you can flag each wall as many times as you want, the more the better. And same goes for the landing. So it's smart enough that it knows which landing you've flagged multiple times since they are on different levels in your scan. So I'll flag this top one again, finish on the April tag, and then hit finish mapping. Let my scan process sped up a bit, but in a matter of seconds right on the tablet. And then have a look right away at my unoptimized data set. As always, I want to pan around my scan and make sure there wasn't any areas that I missed and needed to be appended. And I see the green scene is ready for optimization, so I hit Global Optimization and Save, where we see this new window that shows I recognize that you flagged 4 landing floors and 4, 3, 3, 2 of each of these different walls that are parallel to each other. So I'm going to use those as plane constraints during my staircase optimization. So you of course then just want to select Continue with Plane Constraints. And now my data optimizes as always, typically in a matter of a minute or two, depending on the size of your scan, locally here on the tablet. And in the case of staircase scanning functionality, as soon as it finishes, it will auto-prompt you to save the file. So we'll want to save that to the .product DP format as stairs, and then hit Save Scene as we don't have a coordinate system set yet. So that saves locally onto the hard drive of the tablet. And then we can have a look at our optimized dataset after saving. Looks like a beautiful scan of the staircase in its entirety, and the first thing I usually do is set a coordinate system. So I'm going to zoom down to the first landing here and select to set an origin point on the floor, and then my primary z-axis up out of the floor, and my secondary x-axis out of the wall. by tapping the wall. Now, every point in this cloud has been referenced to that 0, 0, 0 origin point on the bottom landing. So what I can do now is move from the Coordinates tab to the Measurement tab and immediately take a measurement from my bottom landing to my second landing, giving me not only that point-to-point distance of 2.19 meters, but also my change in x, y, and z based off the coordinate system that was just set with the tap of my fingers, so 1.21 meters in height from landing to landing. So now that I've fully processed my data and set the coordinate system, I want to save my scene again. So I'll go to the File tab and select Save Scene, and indicate here that I've optimized and set the coordinates in this scan before hitting Continue, and then make sure to select the user-defined coordinate system as the applied transform that was just set. The next steps from here would be to move on to .3D on Android or Windows for more editing, measurement, annotation, and analysis, or any of our other partner 3D CAD or point cloud applications for further work with the data. For any additional questions, please visit www.dotproduct3d.com.